And somebody will tell us that we're going live in just a moment. I'm sure they will. It's going to happen eventually. It'll come from somewhere. Oh, hey, we're live, everybody. Isn't that wonderful? Welcome to the show. Yes, we're going to start this show here. I hope the audio quality is sounding all right because we are going to begin in 3, 2. This is TWIS. This Week in Science, episode number 696, recorded on Wednesday, November 21st, 19?
That's not even.
Let me just add this to the number of ways that this show is starting late. Starting in 3, 2. This is TWIS. This Week in Science, episode number 696, recorded on Wednesday, November 21st, 2018. TWISGiving 2018. Hey everyone, I'm Dr. Kiki, and tonight on This Week in Science, we are going to fill your head with a little brain activity, poop cubes, and pouring rain. But first,
Disclaimer. Giving thanks, that thing we do once a year, and then go about taking everything and everyone for granted all over again. And at times, depending where you are standing in the world, when you look about, it may be difficult to find things to be thankful for. So here are a few starters. Be thankful for friends and or family. Unless you haven't got such folks, in which case, be thankful for your good health. Unless your health happens to be failing you, in which case, be thankful for sunny days. Unless you are in drought, in which case, be thankful for rainy days. Unless you live in a floodplain. Be thankful that there are at least we are all safe at this moment from immediate danger. Unless we aren't, in which case, can I hide with you? But the point is, humans have been surviving for as long as there have been humans on the planet. And if there's one thing we should all be thankful for this year, is that we humans are a resilient bunch of hairless apes. That no matter what feast or famine of good times or bad are thrown our way, we eventually make it to the other side. And nowhere is the mettle of our resolve, the determination of will, and fierce glint of persistence in the eyes of humanity more blindingly apparent than right here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin and Blair and everyone out there. Welcome to another episode of This Week in Science. We are back once again to talk about all the science that we loved this week, all the science that filled us with awe and wonder and curiosity and made us go, let's talk about that. Let's just talk about that. So today, I'm glad to be back on TWIS. Missed an episode last week, but had a lot of fun going to Huntsville, Alabama for a little thing called ThinkerCon. It's very exciting. I met people. It was fun. I thought a bit. And now I'm back. Yeah. And the inmates were running the asylum while I was gone, apparently.
Yes, that is true. Hopefully we did all right in what you may have noticed during your editing so far. But yeah, we got through. We talked some good science.
You did.
Yeah.
And it was wonderful. Thank you so much for holding down the fort so that I could go off and science with other people.
Our pleasure.
Yeah. Well, we're back. All the science. Lots of science news. I have stories about scientists making cell mimics and little brains. Oh, the things the scientists are getting up to. And we also have an interview this evening with Dr. Andrew Maynard from Arizona State University about Risk and his favorite science fiction movies. But before we get there, Justin, what do you have for us?
I have longer life through mice. And when it rains, it pours. Literally, it's not an analogy for something else.
All right. It does. It always rains in Portland. Portland.
Ha, 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 ha.
Okay, Blair, what's in the animal corner?
Oh my gosh, you're in for a doozy. I brought wombat poop, I brought bear teeth, and I brought a dormant fish fetus.
All the things. You brought all the things. I'm glad you packed for the show.
Yeah, it's like Thanksgiving.
All right. As we jump into the show, I want to remind everyone that you can subscribe to TWIS on iTunes, in the Google Play podcast portal, Stitcher, Spreaker, and TuneIn, all the places good podcasts are found. If you can't remember, just look for TWIS. TWIS.org is a great place to find information. Also, This Week in Science in YouTube and Facebook. And if you go to TWIS.org, you can find information about our 2019 TWIS Blair's Animal Corner calendar, because it's there. But now it's time for our interview. And I would love to welcome to the show Dr. Andrew Maynard. He is a former physicist, a professor in the Arizona State University School for the Future of Innovation and Society. He is a future thinking kind of person, a leading expert in the responsible development of emerging and converging technologies. And he directs the ASU Risk Innovation Lab and chairs the ASU Master of Science and Technology Policy Program. He also writes regularly for several popular science publications and recently published a book called Films from the Future: The Technology and Morality of Sci-Fi Movies. Welcome to the show.
Great to be here.
It's great to have you here.
Kiki, you described Andrew as a former physicist. How do you forget that much of your training and your learning?
I am so going to regret that.
Yeah, but please do tell us, how did you come to work in this concept of risk and innovation when you have a background in physics? What happened there?
So, well, I worked as a physicist for years, as a research physicist. And the only reason I went into physics was it was the only thing I could do. So when I was a little kid and a teenager, I wanted to save the world, but I was hopeless at everything. So I resigned myself to doing physics instead. And it was only after about 15 years of doing physics that I actually found my footing and realized I could do something else. And that was, so I got involved with nanotech, of all things. I did my PhD in nanotech before anybody knew what nanotechnology was. And I suddenly discovered in the early 2000s that everybody was talking about this and talking about the risks. And that's what segued me into thinking about risk and new technologies.
Yeah, because I think when I first came across your work, you were just talking about nanotechnology in general.
Mm-hmm.
I mean that it was years ago, and you were blogging and writing, and and so I remember the risk stuff, coming up as this, this edge to this very promising emerging technology.
Yep. Yeah. So as soon as people really started investing heavily in nanotechnology, this is 15, 20 years or so ago now, one of the earliest questions was what could possibly go wrong? We're putting these little clumps of atoms and molecules together and we're creating materials that behave in really weird and unusual ways. People began to think back to what happened with genetically modified foods when there was a really big backlash against the technology, and they started wondering, are we going to see the same with nanotech? So we started doing research into all the possible risks, and that's where I began to transition with working with small particles to starting to ask some of these bigger questions about what happens when this stuff gets into the body or into the environment, what could possibly go wrong. And as it happens, there are some things that could go wrong, but actually maybe not as much as we thought at the time.
Yeah, so I think from the research that I've seen, there have been issues with small nanoparticles that are inhaled by people, causing lung cancer. How you say that the risks maybe haven't come out to be that terrible. What are the risks, and
Yeah,
what are the
so
promises still now that it's
oh,
like
oh, oh,
decades in?
so the promise is still absolutely huge. So this is going to be a great segue to the book, because strangely enough, I write a little bit about nanotech in the book. But what you find is, so what we can do with nanotechnology, and I actually don't like the term, it's really just nanoscale science and engineering. We're taking atoms and molecules and think of them as the base code of materials. So just like you program or code in ones and zeros if you're on a computer, we're coding with the ones and zeros of atoms and molecules. And as soon as we can do that, when we know how to put them together in really unusual ways, we can create materials with very unusual properties. So make super strong materials, highly conductive, make materials that bend light in very unusual ways indeed. And all this is going on still. People are really working out how to do quite amazing things with this ability to code in atoms and molecules. But of course, we still have the problem that if you create a material that behaves in a way that nothing has ever behaved before, how do we know that it's going to be safe if you inhale it or you put it out onto the land and it gets into plants and things? And then we're still finding out that there are some of these materials that behave in ways that we probably don't want them actually doing, or we don't actually want people coming into contact with them.
Yeah, I did.
For example.
Okay.
Yeah. So for example, so a couple of examples. Now, it was discovered that if you snort really, really small particles, these are particles smaller than about 30 nanometers or so. So think of an atom as around about 1/10 of a nanometer. So these are about 300 atoms across. If you snort them and they get up into your nose, some of them will actually go up your olfactory nerve and get into your brain. Actually, totally way things normally get into your brain by going up this nerve. And we're not actually quite sure whether that's a good thing or a bad thing. Well, it's probably a bad thing, but we actually know what it does. But it seems reasonable to assume that you really don't want unusual particles weaving their way up into your brain through your nose.
Yeah, I'm gonna go with that.
I'm not, though. I'm not. And the reason I'm not is because I don't know what the definition of an unusual molecule is. Because this is like, I've heard that being around sawdust can cause cancer. So that means everybody in the history of woodworking has exposed themselves to particles that they were inhaling that they might not have. But there isn't a perfect, clean way of being on the planet to begin with.
Yep, and that is so important. So and this is why I actually don't like talking about nanomaterials and nanotechnology from a risk perspective, because the range of things that can cause harm or even kill you is much greater than just those small particles. At the same time, if we're creating things that we really don't want in the body, and so, for instance, one of the things that these small particles will do is, if you create them at just the right size, they can have a really chemically active surface. So now if you think about putting something into your brain which is chemically active, it's going to begin to break down certainly the layers around the outside of cells. If it gets to the nucleus of the cell, it can start messing around with the DNA. That's a potential concern. But it's not so much the size, apart from the fact that the big ones don't weevil up the nose, but it's the fact that you're putting something which is chemically active in the body.
Right. You don't want something that will interact with the body. Very often cells in the body defend themselves and they get rid of junk that's not supposed to be there. We have cellular mechanisms for that. But if you have a compound that is actually going to molecularly interact, cause a signaling cascade to take place, that's where things go awry.
It absolutely is. And actually, so to give you another example, you take something like carbon nanotubes, which are these really long strands of carbon molecules, and some of them look remarkably like asbestos fibers. And we know that the long type of carbon nanotube, things such as frustrated phagocytosis, which is where you inhale it, and the phagocytes, these macrophages, these cells that are designed to clear things out of the lungs, they can't wrap themselves around these carbon nanotubes. So they die in the process. And as they've died, they signal other cells to come and clean up the mess, and they die as well. So you have a cascade effect
of cell death.
Yes.
So we got to keep the carbon nanotubes in concrete or wherever they're supposed to be.
Keep them where they're doing the good, and just don't let them out, and everything's great.
Don't let them out to run around amongst the public. So moving on from nanotechnology and kind of segueing more into this idea of just risk assessment and how it relates to innovation generally, can you tell us a bit more about how you start assessing things like this and what role Arizona State University and what you're doing there
Sure.
is
Yeah.
playing in this field of what we are going to be doing in the future?
Yeah. So the short answer is it's incredibly difficult because it's the future and we've no idea what's going to happen. But at the same time, if we're developing really powerful new technologies, it seems to make sense to ask questions about what could go wrong and how we prevent it happening. It's not good enough to say we've no idea, so we're going to try everything and just see what happens, because the chances are we're going to do something where we can't turn the clock back. So when I think about risk, I think about what can we do to try and reduce the chances of something either really bad happening or make sure that we can actually take a step back, a little bit dicey. And a lot of this comes down to ideas about what it means to be responsible in innovation. And risk is at the core of that, because risk is about bad things happening that we don't want to happen. But being responsible, rather than doing the full risk assessment, which we can't do because it's the future, it involves things like just sitting down and asking, well, what could possibly go wrong if we do A? And if it looks really bad, why don't we do B instead? And can we find an option A, B, C, or D where our future projections actually look better than the others? So it's taking those first steps to at least trying to work out what could go wrong and steering things towards a future where things are less likely to go wrong.
And so, of course, you talk to science fiction authors and movie producers.
Of course, actually, really, it's just an excuse to talk to sci-fi writers. It's nothing to do with the science, but don't tell anyone that. So no, I know.
To be fair, I always think of a lot of these the science fiction of the future that takes on technology that's either now or showing up soon. They extrapolate, and I feel like they tend to be pretty decent prospectors for extrapolating out what ills could happen with like an AI or AI robotics, or sometimes it's just benign or beneficial. Star Trek with cell phones,
Right?
It was just a normal thing for them and a very helpful tool going forward.
Yeah, so they can. So one of the challenges is that science fiction writers or movie makers, they're always looking for that narrative tension. So there's always a tendency to overemphasize or overegg the risks there. And because of that, it's a little dangerous to use, say, a sci-fi movie as a predictor of future technologies. What they're really good at, though, is saying something about our relationship with those technologies. So if you think about risk in terms of social risks, what could go wrong as soon as you put a powerful technology face to face with a bunch of people? Sci-fi is really good at looking at what's likely to happen there, because at the end of the day, these are stories about people and about society.
And one topic in the show that comes up over and over again is the reanimation of extinct species. And in the first chapter of your book, you talk a bit about this, about that wonderful movie series that spawned a series of movies because of spawning dinosaurs from the blood of a mosquito, Jurassic Park.
Yes, Jurassic Park.
Can you talk a little bit about how that movie and the story it told dealt with those human issues and risk?
Yeah. So it's funny writing the book on older movies, and I remember when Jurassic Park came out in 1993, and it's amazing how well it stands the test of time, just as good storytelling. But of course, that's a story not only about bringing dinosaurs back to life by genetically engineering them out of the strands of DNA from mosquitoes, which actually we can't do, but we'll put that to one side for a moment. But it's also a story about scientific hubris. It's a story about scientists that do stuff just because they can, and a very wealthy entrepreneur who funds stuff just because he can without thinking about the consequences. And what I love about that movie is it's a huge warning against doing science and doing technology just because we can without actually thinking about what could go wrong. But also it's a hugely positive story about the natural world. And what I always take away when I watch it these days is you listen to the soundtrack, triumphant soundtrack. And it's triumphant because it says nature wins at the end of the day. It doesn't matter what us puny humans do. Nature will win out.
So that's an interesting concept, because the first thing I thought of was Frankenstein, right? He reanimates the dead because he figures out how to do it and is not as concerned about what brain he's put in or what the consequences will be.
Yeah.
How he didn't poll the townspeople with their pitchforks ahead of time.
Sure, and actually, and if you go back to Frankenstein, it's that lack of respect he had as well. And actually, you see this echoed in Jurassic Park. He didn't respect his creation, and that's what came back to bite him.
Mm-hmm.
Yeah, but then I also then immediately thought of the invent of electricity, Edison versus Tesla, and Edison doing the campaign of trying to show the evils of alternating current by electrocuting dogs and Topsy the elephant, but at the same time more than willing to put direct current out into the world with no afterthought. But without that desire to create despite or just in indifference. How do we get those things? I mean, if you tried to telegraph, okay, we're going to invent electricity, let's think about all the possible negative effects that could come from, and it would probably just come up to like fires, and they wouldn't get much further than that. Like, we could cause too many fires. Okay, we won't do it. Like, there's a point where you just have to throw it into the world and let the world adjust to it.
So, and I think this is the big mistake that some people make, thinking that it's an either do we invent or don't we? There's a really interesting middle line there that says, yes, let's do the cool stuff. Let's invent things. Let's see what happens. But let's be a little bit thoughtful while we're doing it. Not thoughtful to say, should we, shouldn't we? But thoughtful to say, how should we do this? And so you go back to the electricity example. Now, if those conversations, whether they're about DC or AC, were not about do we, don't we, but how do we do this in the best possible way, we might actually have better systems now than we have.
I think this actually speaks to a conversation we constantly have on the show, which is about autonomous cars. We're constantly talking about that. It makes me pretty nervous. I have slowly sort of been cajoled into being potentially okay with it, because I have some friends who have a Tesla and they've had me drive the car when it's doing its own thing and stuff like that. And it's less terrifying to me. But I think this is exactly the stuff that I need to be hearing to be okay with these sorts of things, is that somebody is calculating risk and being careful about the rollout.
Yeah, and it's that being careful, which I think is important. And so funny with the autonomous vehicles, sitting here in Tempe, Arizona, which is a test bed of these, and you can't go anywhere without seeing them on the roads. It's been fascinating to see the evolution, especially the company Waymo, that's been the dominant company here. And the amazing thing is just how accepting people have been of I've almost likened it to great. I've almost likened it to the invention of the MP3 player, the iPod, where before it came along, nobody knew they wanted it or needed it. After it came out, nobody could imagine living without it. I think it's going to be the same with self-driving cars. So we can have all these conversations about how dangerous they might be, who they're going to hit if they have to make a decision, and all these hypotheticals. As soon as people experience them, all that's out of the window, and it's how can I get one as fast as possible?
And what's also funny about that, who do they hit if they can't get out of the way or something? But the predecessor to that was a human question of, you could pull, like, I think a trolley car track.
Yes.
And that question never got resolved. Like, there was never a right answer to even that question. So it
Yeah.
almost makes it mute that the AI can't figure it out any better than we humans.
So I've got to say, and so lateral thinking is so important here. The best solution I've ever heard to the trolley problem, which is that the problem of if a car has to sort of kill, I don't know, 10 old people or sort of 3 kids or whatever it is, the best answer I've heard is put an airbag on the front.
Okay, right. Yeah,
Have
just
a
make it a little bit
solution,
less
make it
risky
safer.
for everybody who gets hit. Fantastic.
Exactly.
Yeah.
So this question of self-driving cars, besides the danger to the public from these autonomous vehicles, there's the more cultural question of job displacement. And
Yep.
if you suddenly have a fleet of these vehicles and they're taking the jobs of all of the taxi and Lyft and Uber drivers, and then also trucks taking goods from place to place and buses around cities, suddenly jobs are at a premium. So that is a more cultural question. What movies do you think that were in the list of movies you looked at
Yeah.
that really get at this kind of the cultural aspects of these technologies?
So actually, it's something that I pull out with every movie, and I'm so glad you brought that up, because when we talk about risk, it's often these cultural things, these things that are so important to us that really determine how we make decisions. But if you look at jobs, there are a couple of movies that touch on that, and I'm trying to think about the one where I really focus on it. But one of them is the movie Elysium, and I should preface this by saying, I use a whole range of movies in this book. Some of them did not do that well with the critics. And Elysium sort of was on the borderline. It is such an earnest and over earnest movie about the 1% of the uber rich living off Earth and everybody else sort of slaving away on Earth. But it tells an interesting story about jobs. And what it does is it tells a story of technology not necessarily taking jobs away, but leaving people doing very menial tasks, because it's cheaper to give a menial task to a person than it is to a robot. So now you have a lot of people living very impoverished lives because of the way that the rich are using technologies. And it's a really good example of how we begin to talk about social equity in technologies, making sure that technologies don't increase the divide between the haves and the have-nots.
So, the one I would throw out there would be, to answer your question, Kiki, would be Star Trek.
Right.
Where money has sort of been removed, and your sort of gravitas of your income. Like Kirk's, if you ever noticed, the captain's quarters on the Enterprise are no bigger, better, or elaborate than anybody else's. He just gets to a little extra swagger because he's the captain.
That's right. Yes. Yeah. Yeah.
And so there is this sort of divergent future which becomes a political issue too, but where we realize humans won't be necessarily as required for the labor or the being the center of industry of an economy.
Yeah.
And that emphasis will go elsewhere, and we'll have to find roles for humans that aren't based on economic value.
Right. And of course, that brings up the whole social side, which is why I'm so interested in this, because everything comes down to how do we construct a society that works well? How do we fit people into that? Or how do people find their way in that, where they actually build worth and value for themselves?
And so we're looking at you've written this book about these science fiction movies that are obviously looking into the future, and we're talking about the future of innovation, but what about lessons from the past? So we can look at things like petroleum, how it's affecting the environment, and climate change currently, plastics in the environment. We can also, talk about the non-stick coating POFAs that have gotten into the environment from the chemical industry. And we can look at these things from the past and what's happened. Are those lessons things that we can take into the future to teach us about risk?
Oh, yeah. Could they have been predicted?
Right. Yeah. Well, the answer is I wish they had have done. And there are so many cases where the science just got squashed by commercial interests. There's a long history of this. So the book doesn't look at this too much. It actually looks at it a little bit. But that's not to say it's not important. In fact, it's tremendously important. It reminds me, there was a report that came out of Europe a few years ago now called Late Lessons from Early Warnings that looked at exactly this. It looked at a number of cases of where really bad decisions had been made around materials, around technologies that led to environmental harm, human health impacts, and even death. And in almost every case, the science was there. We knew how to use these things wisely. It's just that people didn't pay attention to the science. And so the big, loud, screaming answer or screaming lesson out of that is listen to the science as we work out how to use these technologies sensibly.
I wonder if there's any way. I mean, we're looking at, Uber, which obviously has, is this company that's pushing forward a lot of the adoption of these, like Waymo as well, but has there are questions about the ethics of the company and how the company is even working towards this, of the autonomous vehicles. There are other companies that have their own biases. How do we balance the science and the capitalistic drive, for public safety as we move forward?
No, carry on, Justin.
Oh, so I mean, I was just going to throw in a real quick thing. Like, I guess it depends on your perspective of safety. So for instance, the greatest argument for the autonomous car might be that you no longer have people who are alcoholically inhibited behind the wheel making bad decisions.
Absolutely.
I mean, so like there's
but that's not my question.
Can make
That's not my question though. Can we let Andrew answer my question? No, it's not my question.
What was the question?
I'm wondering how we can balance this, the apparent availability of scientific evidence that can be used as advice.
So
there are the capitalistic tendencies that sometimes don't care.
That's right. One of the problems is we live in a market-driven society, so you're never going to get anything perfect or anywhere close to perfect because money drives everything. On the other hand, I think that we can make some differences which increase the chances of good coming out of stuff. So for instance, if you talk to young entrepreneurs, I used to teach a class of entrepreneurs when I was at the University of Michigan, and you talk to them about what they want to do. Very rarely will you come across anybody who says, I want to make a lot of money. They'll say, I want to make the world a better place. I want to clean up the environment. I want to get rid of sickness and disease. And these are all genuine answers. So people that are going into being entrepreneurs, being innovators, creating startup companies, they want to do good. They have a desperate desire to do good, but they don't have all the tools they need to do that. So one of the things we can do is help those people understand how they can make smart decisions early on in the process so they don't get themselves in a really big mess further down the line. So in effect, this is a really trite example. Think about Facebook. What if Mark Zuckerberg and others had thought right from the get-go, how can we actually develop a framework for Facebook so we're going to make sure we're doing good, not bad, and we're going to put checks and balances in there rather than thinking now, whoops, we've got a real mess on our hands. Life might have been very different for them. And I think you can actually teach entrepreneurs how to do that. And in fact, this sounds so trite when I say it, but one of the reasons I wrote the book is the idea that you can't just go to an innovator and say, hey, you ought to innovate responsibly, because they'll look at you and say, what are you talking about? Of course I innovate responsibly. But if you talk to them about what they can learn from science fiction movies, it gets underneath those barriers and it helps them see their world in a different way. So this is one really small thing that we can do. And from those small steps, you can begin larger conversations about what actually it means to innovate responsibly and still make a profit in business.
So kind of to follow up on that, I read a lot of, this is such a science nerdy thing, so good. I read a lot of blogs and research papers about social science and the type of people that care about technology and visit cultural institutions and science museums and stuff like that. And a lot of the stuff that's kind of rising up to a lot of these research papers has to do with these generational differences, right? And so is this something potentially that will happen somewhat naturally with the rise of millennials in leadership roles in these technological companies? Because this is a millennial thing for all the flack millennials get. They're very focused on this making a difference and this more ethereal goal set and this idea that technology and science is something of value and kind of part of this big picture. Do you think some of this might just happen naturally?
I actually don't, but I wish it would. So I think it's incredibly exciting when you see that younger generation get very enthusiastic about the social side of things. And we actually see that reflected in our students, the number of science and engineering students who want to know how to expand their understanding of society so they can make a positive difference. But the reason why I don't think it'll happen naturally is you see people really quickly, as soon as they get into business, slip from being very altruistic and very focused on benefiting society to working out how they're going to pay the bills, how they're actually going to survive another week, 2 weeks, 4 weeks.
Yep.
And the harsh reality is that unless they've got an operationalized framework for doing good, they slip into doing business as normal too fast.
So how do we keep it?
Yeah.
How do we foster that?
Yeah, it has to be set into how they're trained to do business.
We actually have to start with the training. So scientists and engineers, we actually have to integrate into that training what it means to be socially responsible. And so that's not just a bolt-on ethics course, say with engineering, but it's teaching engineers what it actually means to be a productive part of society, not just making the gizmos, but understanding how those then propagate through society. Once you've done that, you then need to be able to give them the tools and the ways of thinking to do their stuff in the best possible way.
Yeah, not can you build the 3D printer to make lots of plastic tchotchkes, but what actually can be made with this plastic using 3D printer that is useful to society?
That's right. And actually, going back to an earlier question, if you develop that mindset and those tools, rather than inhibiting innovation, you actually amplify innovation because now people can see how they can do things that they really wanted to do.
That's brilliant. So in your book, at one point, you bring up not just science, technology, engineering, but art, and bring up the idea that art can be used to be able to get people communicating across communicational barriers. So can you talk a little bit about how you see that being used?
And I make the very pretentious statement that even some of these science fiction movies can be considered as art. I find art fascinating because it gives you a route to empathy. And so if you go back to asking, well, what can entrepreneurs or engineers do? One of the most important things is their ability to put themselves in somebody else's shoes and see the world from somebody else's position. One of the ways to do that is through art. Art is both a great leveler because you can have people from very different backgrounds appreciate art. It's a point of focus that actually helps build bridges. But it's also a way of building empathy in very, very sort of qualitative, soft ways, but you can use it to help people see what the world looks like from somebody else's perspective and appreciate what they can do to build that world and add value to that other person, whether that's performance art, whether it's reading novels, whether it's looking at paintings, whatever.
I think it's wonderful. And what is your favorite, as we're getting to the end of the interview here, your favorite science fiction movie and lesson that it could teach us?
Goodness. So I must confess that the book has got 12 core movies and I love them all. I've lived with them so long now. Every one of them has got something special, but there are two in there that have a special place in my heart. The first one is a Japanese anime, Ghost in the Shell, 1995 version, not the recent remake, which was really not very good. It's not an easy movie, but it is beautiful. And it's beautiful because it's really taking a very meditative look at what it means to be human, especially as we increase the amount of technology in our bodies. And I love it for that because it makes you think, and it makes you think hard about the nature of life, humanity, personhood, diversity. Great movie. The other one is a movie that isn't widely known over in the US called Never Let Go. It's based on the book by Kazuo Ishiguro, a British writer. And it's not really a science fiction movie. It's a movie about a group of young kids who grow up into early adulthood, but they're in a program where they're clones and they're basically being grown and nurtured so their organs can be harvested. And what I love about it is it focuses on the deeply personal impacts of a technology that society has decided it's too important not to invest in. And it's a movie that rips my heart out every time I see it. I teach a class on these movies, and I'm sort of this last year sort of sitting at the back of the class. Thankfully, it's dark, sort of tears stream down my face because it's such a moving movie. But it shows how good intentions with a technology can utterly destroy lives if we don't think about what we're doing.
So my all-time favorite sci-fi movie is Buckaroo Banzai.
Oh no, please.
Yes. And the reason is I think that's where humanity has to get to the Buckaroo Banzai crew at some point, because they are scientists. But they also like don't have to have day-to-day jobs. So they're also musicians and artists. And they work on like you can do this sort of like it's actually an ancient samurai thing where you have to be good at painting as well as Warcraft. You have to be well-rounded. And the fact that, as goofy a movie as this is, the fact that they endeavor, each of them, to be a little bit more, even Mr. Perfect tries to be a little bit more well-rounded and pursuits, is the thing that we will all need as technology advances and takes away aspects that were purely human endeavors. You know, we need to be able to be flexible in what it means to be a human and what we're adding to the world.
I really like that, actually. Yeah, so I really don't like the movie, but I really like that interpretation.
Yeah.
We can always find a little nugget of gold in there somewhere. Your take-home message for people. I'd love to know what you'd like to tell people about emerging technologies and the future of
Okay, so 3 take-home messages. Emerging technologies are more powerful than you would ever imagine. There's weirder stuff than you could get your head around happening, and it's going to get weirder and more exciting and more wonderful over the next decade or so. So that's number 1. Number 2 is, because it's so weird and exciting and unusual, the potential risks of something going wrong are accelerating. So that creates a really sort of big tension. And so the third takeaway is, if we're going to ride this wave, if we're really going to revel in these new technologies and see the true benefits, we've got to adjust our heads and think differently about what it means to do it responsibly.
Absolutely. And where can people find your book?
Everywhere that good books are sold. So Amazon, Barnes & Noble. I was told it's even being sold through Target. So pretty much anywhere where books are sold, it's there.
That's fabulous. All right. So if you're interested, the book is called Films from the Future. And it is a wonderful, wonderful investigation of multiple science fiction films. If you're a fan of science fiction, gets you into the heart of those human issues related to these technologies that will change our lives. Andrew, thank you so much for joining us today on the show.
Thank you. It's been a pleasure.
It's been wonderful speaking with you. So have a wonderful evening. We are going to move on to the rest of our show. We've got stories ahead, everyone. We're about to take a quick break. So everyone out there, we'll be back with more science. We've got mini brains, we've got pouring rain, and we've got poop cubes all coming up next. Stay tuned for more This Week in Science.
Can't explain things you've heard more than intuition. A line freeze that shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere within this scatter plot.
Hello, everyone. I would love to say thank you. Thank you on this TWISGiving show for you being here with us. Thank you for sharing your time with us. We are so glad to share wonderful science with you and conversations about the future of humanity like we just had with Dr. Andrew Maynard. And in the meantime, I would also like to let you know a few things. So, out there in the world, there's a lot of holidays coming up. It's Black Friday, right? There's the holidays coming, and then it's going to be 2019. And what are you going to do with your time? Well, maybe you could plan it out with a calendar. That's right. TWIS has its 2019 TWIS Blair's Animal Corner calendar that is available now. It is at our website. I'm trying to find my webpage. I have issues with me and myself and where I place these web pages, but here it is. Okay. Our webpage, twis.org. If you go to twis.org, you can go click on the Toady Goodness TWIS 2019 image that is on the website. You can pre-order your calendar. I just put in the order for the calendars themselves, so hopefully they'll be getting here soon and I'll be able to start mailing them out come December, which would be amazing to get them to you before 2019 begins. But click on that image. I will mail you calendars. And I hope you enjoy a year full of art produced by Blair. She made an amazing calendar for you once again. And I hope you decide to take us up on this amazing offer and order your calendar now. Go to twis.org and do that. Additionally, if you're looking for other gifts for people or for yourself, you can click on our Zazzle store link. You click on that Zazzle store link, it will take you to our Zazzle store where you can find all sorts of amazing products with the TWIS logo on it. Or products from previous Blair's Animal Corner calendars, like lumbar pillow. You could get a lumbar pillow with a mammoth on it. It's beautiful. It's a work of art. It's also science. And a portion of the proceeds go to support TWIS. And isn't that what you want to do with your holiday giving and your goodness? That's right. Other ways you can help TWIS out this holiday season is just by simply donating. So you can scroll down the page and there is a yellow donation button. Click on that. It'll take you to a PayPal interface for donating any amount of your choosing. Also, if you click on any episode, the most recent episode, for example, you can scroll all the way down through the show notes, check it all out there, and click on the pink buttons at the bottom of the page. These are for recurring donations. You can donate $2, $5, or $10 a month in a recurring fashion. Now, if you're not too into PayPal, that's all right because, we have a Patreon community and you can click on that Patreon link. It will take you to patreon.com/thisweekinscience, where again, you can sign up to donate on a recurring basis as one amount every month, set it and forget it, and know you're constantly supporting and giving to your favorite science podcast. That's right. And we give you little gifts in return. So maybe check out that $10 a month tier. Like each episode, that's around a cup of coffee, the same amount for a cup of coffee, because we do about 4 or maybe 5 episodes a month. And so for the cost of about a cup of coffee, you're going to be supporting us and we will thank you by name on the show. So $10 a month, click that tier and we will love thanking you on the show, on every episode. Last thing you can do if you haven't already done it is just subscribe. There's a big orange subscribe button. Click on that button. It'll allow you to check out various ways to subscribe to the TWIS podcast, your choosing. And you can send other people here for them to subscribe. So there you go. These are all the ways that you can help TWIS do what we do. And we hope that you do continue to help us. We hope that you continue to listen. This is This Week in Science. And really, we could not do any of this without you. So thank you for your support.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go. new conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere.
And we are back with more This Week in Science.
We're back. We got the science for you, but right now we got another thing. It's called This Weekend. What has science done for me lately?
Oh, we're getting worse.
Says you.
As you. All right. So this week being TWISGiving, I wrote a thanks to science. I wrote it this week. I put your voices in it as well.
Oh, good.
I wrote it for us.
Great.
What has science done for me lately? Well, it is TWISGiving, and I would like to say this week we here at This Week in Science are grateful for the science that allows us to podcast and stream so that we can talk about science with you. We are grateful for scientists who endeavor around the clock to discover more about the world around us so that we can talk about that science with you. We are grateful for those who shine a light on the failings of the scientific institutions so that science may one day better represent the world around it and so that we can discuss the improvements to science with you. We are also grateful to science for helping us all to live healthier, longer, more fruitful lives so that we can share our lives with you. We are grateful that you share your time with us.
Yeah.
All the warm fuzzies.
Oh, I warm fuzzied you. Well, it's true. All of it, every word of it is true. And I thank all of you out there. I thank my co-hosts as well.
I'm thankful for you.
Oh, we got sniffles. Yeah, it is a time for gratitude, and I'm very grateful for all of this. Thank you, science. Thank you all. And everyone, remember, if you would like to write in with a what has science done for you lately, you can send me an email, kirsten@thisweekinscience.com, or send me a message on Facebook. That's right. Look for our Facebook page, This Week in Science. What you look for. And you can send me a message directly with your what has science done for you lately. Help us keep filling up this segment of the show. That's what we like to do. And we want your voices to fill it. It's not about me. It's about you. And it's about the science. So let's do that. Let's do this. Can we do this? We can do this. Send me letters, everyone. Okay. Time for science.
Time for science.
Are you ready for some artificial pseudocells?
Are you ready for? Huh?
What?
Artificial
pseudocells. So we talk a lot about synthetic biology on the show, and we've talked about work that is trying to use existing cells, biological structures, to create other biological structures. And this is a different way around it, where they've taken inspiration from biology to create cell mimics, but that aren't made of biological stuff at all. So the UC San Diego team that created this, they're using artificial structures, and so instead of a cell membrane that's made up of a lipid bilayer, just fats with their tails to the interior that separate the inside of the cell from a water-filled exterior. They actually are using a plastic polymer for their cell wall. They're also creating an interior of the cell. They have a silicon chip with microscopic fluid-filled channels that extrude droplets of raw material like DNA. They use minerals from clay and acrylate molecules. So there's molecules, but not really the way you would find them in normal cells. They use ultraviolet light and chemical treatment to create this porous membrane around these droplets of DNA and clay minerals, and the minerals in the DNA condense into a gel that's kind of like a soft contact lens, according to this article from Science News. And they have something that's like a nucleus that's not really a nucleus. Everything is very similar and has this. It's like, I think I've seen something like this before, but it's not the way you'd see it in a normal cell.
So I'm chuckling over here because I suddenly had this picture of the PhD version of a science fair volcano, right? Where you're like, it's like a volcano, but it's made out of paper mache and it erupts like a volcano, but it's really just vinegar and baking soda. So this is that.
It is, but for cells, it's a mimic. And you might be wondering, why are you gonna make not a cell, something that's so similar to a cell but isn't a cell? And so the idea is that maybe these cell mimic structures could be used to do things that natural cells couldn't. And to have certain functions in environments in ways and be controlled in ways that natural cells wouldn't necessarily be able to be controlled. But one of the really interesting things, the thing that really gets at this, it's not just, oh, they made a made up cell. It's not just an art project. They want to make these things function and have and play roles in environments. And so for some of these experiments, they put green fluorescent protein, GFP, with the DNA. And some of the cells made this green fluorescent protein and some of them didn't. But some of the other cells had a sticky stretch of DNA that captured green fluorescent protein molecules. And so they added a bunch of enzymes and ribosomes to these cells so that they could do protein synthesis functions. And they made it all go. Hey, here, cells, do what you're going to do. And they saw that not only did the molecular machinery and the green fluorescent protein cross the barriers between the cells, but then the cells that didn't have the green fluorescent protein started making they got it and they started making it. And even beyond that, they started working in a way that's very similar to bacterial cells, in that there was a threshold level of activation that was necessary to turn the green fluorescent protein on. So they basically had a sort of quorum sensing where they wouldn't turn on and do what they were supposed to do unless enough of them had the green fluorescent protein to really make it work. And so this is something that we see happen in biological cells in bacteria, where a certain number of them have to reach a certain quorum of sensing a concentration of something in the environment to act on it or against it. Anyway, they've got, just with these made up cell mimics, some biological functions, which is very interesting. And then additionally, they're super durable. The researchers put these cell mimics in a freezer for 2 years and they were just fine.
Years?
Yeah,
Wow.
they froze them for 2 years and they were just fine. They didn't have any problems with dehydration or anything related to the freezing process.
Yeah. Wow. Now that's potentially huge. That by itself.
Yeah. So it's a really interesting it's really an interesting model system, and it could be used to, in parallel, study synthetic biology and the development of cells and how cells came to be. I mean, I find it interesting that they're like, here, let's put clay molecules and other things, and we'll give you some ultraviolet light and some some chemical activation and primordial soup. Anyone?
Mm-hmm.
I'm seeing parallels to evolution happening in this laboratory experiment. Yeah, there's if they could potentially make the cells be able to grow and divide, that would be another big step in this.
That would be. Although already when you said ribosome, my first thought was, where did they acquire this?
Yeah, probably. Yeah, they've got it.
This is, I
Probably
mean,
from
this is a
somewhere.
biological
Yeah.
DNA thing. Like it's, so they didn't completely. This is maybe why this is a mimic and not a synthetic.
Right.
It's
Yeah. Anyway, so synthetic biology,
Frankenstein.
it is Frankensteining it
It's
together.
totally
They're taking cellular biologists are taking all sorts of paths to this creation of synthetic cells. And it's not just that. It's neat to know that there are multiple avenues that are being taken. I think it's very interesting. Beyond that, though, let's talk about mini brains.
Oh, let's do. Are they made out of gelatin? Can I eat them?
Oh,
Stay away from my brain.
and I'm not talking about Justin's brain.
Oh, okay.
No. No. Researchers, again, this is UC San Diego. I don't know what's going on, what they
Oh my God.
water in San Diego these days, but there's some crazy research out right now. So Alison Muotri of UC San Diego, he has been working with stem cells to study developmental disorders and neurodegenerative diseases, basically to study issues related to the brain, like autism and others. And he got, among other people, they've gotten stem cells to turn into brain cells. And then they got the brain cells to start combining together and growing together into a little mini cortex, which is the cognitive information processing part of the brain, right?
Wait, does this mean I can add extra brains now?
Maybe
This
there are
procedure?
there are other experiments that are doing that kind of stuff, and so that is another interesting question. This one, though, is just fascinating in what happened there. So they grew this brain organoid, is what it's called, and these organoids are really interesting because they're not just the nerve cells. In the development, the stem cells end up developing into not just the brain cells themselves, but also the glial cells and also blood vessels. And so previous experiments by other labs have shown mini brains starting to form their own vascularization, which is a huge thing when you're dealing with a tissue. You need a thick amount of tissue to it's got to sustain itself, right? And so they're growing their vascularization. They've got multiple cell types involved. It's a very complex yet tiny little simulacrum of a portion of the brain, right? Now, the idea is that the brain that we get to study is either from dead people. We get brains donated from people who have died. And so there's a question of, how healthy was that brain tissue to begin with? What can we actually use it for? Limited number of brains and tissue to work from. And so it would be really amazing to have brains, human brains to work with. And so this is a middle ground to create these little tiny mini brains. And now the thing that has happened with these brains is they didn't just start turning into little brains. What is the signifying thing that brains do?
I know this. They brain.
They brain.
Well, a lot like if you're talking about like a node of brain or a segment of brain, you have a pretty specific function. Like you have a mathematics center, you have a cognitive center, you have a memory center, so you have all of these different.
But how do they
specific categories of?
how do they transmit information?
Electricity. Pew, pew.
Ion
Exactly.
channel things.
Yeah, so all these nerve cells have ion channels and they are capable of producing electrical activity. And so you'd think a little mini brain would just have an uncoordinated electrical signature. Well, as they started looking at these mini brains as they were growing, they grew for up to 6 months. These little mini brains started having electrical signatures similar to irregular EEG, electroencephalogram patterns that were very similar to the synchronized yet chaotic electrical activity seen in preterm developing babies. And so what we are seeing in these mini brains is spontaneous firing of the neurons in a coordinated fashion. And a tenet of neurobiology is brains that wire together, fire together. And so these little tiny brains are talking within themselves. These
So they're
neurons,
acting like a fetus brain, is what you're saying.
yeah, but not to the extent that it's like a full brain. It's
Right.
just a
No,
little tiny bit.
It's
Yeah.
seeking instructions.
It's
for
exactly. It's seeking information. It's doing what it should be doing. These
Uh-huh.
cells, it's showing that these cells are active in the expected way, that they are working, and that it's not just a lump of brain tissue, but it is a living, functioning lump of brain tissue.
That's so
lump
cool.
of brain tissue to central cortex, awaiting further instruction. Yeah, that's what I want. That's what I want. I want additional parts of my brain that aren't already like on a plan that can do functions that are other parts of the brain are struggling with.
So
want to be
Justin
able
wants
to
the
defer-
octopus
Oh.
setup. He wants
Well, you're
the decentralized brain.
No.
He wants brains in his arms and legs.
kind of, but I mostly want like a recreation of the motor cortex that's in charge of math or in charge of language or in charge of
There's
a thing that I don't consciously have to think about, but can run the calculations for the other parts of my brain so that they don't have to worry about
Yeah.
them.
You're like, I won't be in on Monday. I'm having an extra brain installed. See you Tuesday.
See you Tuesday, maybe Wednesday, but actually I've already ordered the lunch that you want for your birthday, which is different than the lunch you want now because I now know because I've been able to see the future. Look, this is like the dream, like that, to be able to construct architecture within your brain to handle additional capacity and function.
So it's your dream. I don't know. The researchers aren't
that not
necessarily
everybody's
looking at it as a way to add more brain to your brains.
More
But-
brain.
But
Or
potentially the mini brains themselves, the fact that they work, this is a platform for looking at developmental disorders like autism to see where things start going wrong, how different genetic modifications could potentially change that, what treatments may work in addressing developmental disorders related to the brain. We can also start looking at things that aren't necessarily related to development, but maybe related to aging as well. Can we take can we figure out ways that we can help brains age more gracefully? And in the case of other and Motri's in his labs not working on this specifically, but other labs are looking at the possibility of, say, if you have a stroke or a situation where there's a lesion in your brain and some brain tissue has to be removed, could you put new brain tissue in? Could it incorporate back into the brain? And it looks as though with studies with mice that there is some amount of incorporation of transplanted brain tissue of human brain tissue into mouse brains when those studies have been done. However,
but again, these are the baby
extent.
steps. The real goal,
Baby
real
steps.
goal is to increase the brain power of Justin because I've used as much of this.
You know what?
This brain
That's
is
why-
the only limitation I have now.
My brain power comes from an external device called a phone. That's it attaches this device connects me to the internet, which is an amazing storage
what if
of
you
information.
didn't need it? What if
What?
you didn't need that? What
if
you
I
didn't
didn't?
need that? What if you could have a part of your brain that picked up Wi-Fi? I mean, the point
There
of
we
it.
go. Okay,
Well,
sci-fi.
Well, it is, but then so is everything that we're living in today 50 years ago, right? This is how these things work. Is that at some point somebody's like, "Whoa, wireless communication on the fly and self-driving cars and what else? Oh yeah, a way to be in contact with all your family members without ever having to actually talk to them." Like these were the dreams of 50 years ago. And these things just are taken for granted now.
Yeah, maybe one day we will take it for granted. But anyway, baby steps, and the articles have raised issues of concern and controversy about whether or not these electrical signals in human brain tissue are indicative of consciousness.
With
And at this
who?
point,
Who's sweating over the lab details to the point of like, yeah, okay.
researchers,
I'm sorry. Whoever's in the philosophy department who's like jumping on the paper because who has not contributed or written anything should just shut up. And then that's the worst I'm gonna say. Language. Just stop. Yeah, I get that you have nothing to wrap your argumentative mind around in your philosophy department right now, but just stop. You have no business.
I mean, we haven't been able to determine at what point during development consciousness actually begins. We haven't been able to determine whether other animals are conscious. The question of consciousness is still a very
I question it about my
gray
fellow man
all the
with
time.
full cognitive ability
There
to
we go.
vote to this day. So the question will never
It's
be
great.
resolved.
It may
It's a
never be
ridiculous question.
resolved, but it's an interesting question, and I will just leave it with, what if we could create a conscious brain in the dish?
A
Is
la
what
Steve
then?
Martin, the man with two
Yes.
brains.
Yes. What
Man with two
then?
brains.
Yeah.
Or the entree, or maybe the main course at the cafe at the end of the universe.
Right.
That pig that can tell you how it was raised and what part you should eat first.
Or the brains from Futurama. I am a gigantic brain.
All the president heads in the jars. That's like my favorite Futurama thing. Like,
All right,
Brazil.
moving on from brains in jars, let's talk about how to live better longer. We're in the Sci-Fi TWISGiving episode. Thanks for watching, everyone. Justin.
Oh, this is my segue. Yes.
Yes.
One of the downsides to getting older is that hopes you had as a youth begin to turn quickly to regret for not having done more to realize those youthful ideals. None of which has anything to do with the following story, but it's still a good perspective to keep in mind, regardless of your age or what you're doing right now. And now on to the actual story, which is research from the University of Pittsburgh. The so-called longevity protein, Klotho, both as culprit and therapeutic target. The paper published this week in Nature Communications shows in young mice, Klotho expression soars after a muscle injury, whereas in older mice, it remains flat. By raising Klotho levels in older animals or by mitigating downstream effects of Klotho deficiency, the researchers were able to restore muscle regeneration after injury. This is one of the things I think I've talked about a bit on the show as I've gotten older. My mind, my brain has not aged, and it still thinks it can do the physical activities that it could do when I was like 15. And it is only the muscle degeneration recovery mode in the next days after a physical exertion that I realize, aha, the body has aged separately from the mind. This paper published in Nature Communications. Okay, this is quoting voice of lead author Fabrizia Ambrogio, PhD, Director of Rehabilitation for UPMC International, Associate Professor of Physical Medicine and Rehabilitation at Pitt, in person with an almost unbelievably awesome name, says, we found that we were able to rescue, at least in part, the regenerative defect of aged skeletal muscle. We saw functional levels of muscle regeneration in old animals that parallel younger counterparts, suggesting that this could potentially be a therapeutic option down the road, Fabrizia Ambrosio said. Suspecting that Klotho acts through mitochondrial dysfunction, the researchers gave Klotho-deficient animals a mitochondria-targeting drug called SS31, which is in a clinical trial currently. They treated animals. The treated animals grew more muscle tissue at the site of injury compared to untreated controls. The strength after recovery rivaled that of genetically normal mice. So they added this thing that prevented the deficiency of clotho, and they
Ooh,
I think Justin's dying.
Justin needs some clotho, it sounds like.
It sounds like. I know.
the air quality in my neck of the Central Valley is still horrible despite the rain.
Yeah.
So they also injected older animals a few days after injury, resulting in greater muscle mass, better functional recovery than a saline treated counterparts, which I think is funny that they kind of gave a fake treatment to a counterpart in mice, like they were going to be fooled.
Well, you never can tell what variable is going to be confounding. Maybe it's being grabbed and poked. Who knows?
Right.
Yeah,
Okay. Good point.
Yeah.
So normal healthy mice did not benefit from the SS31 after injury. It was just the older mice. So clinically, these findings could translate to older adults who either sustained muscle injury or underwent muscle damaging surgery. Giving them clotho at the appropriate time point, which is very important, could boost their muscle regeneration. So Fabricia Ambrosio cautions that the timing, dosage, route of administration, all the details will require some future research, but that you can't simply bombard muscles with clotho. Cody voice, we do not expect to observe any functional benefit if you bombard the muscle with clotho. We found that mimicking the timing profile we see in young animals seems to be critical. We think that this gives some insight into the therapeutic window.
So there's a window.
I mean, and we speak about this. I spoke about this slightly glibly in terms of being a upper-ish middle-aged, lower middle-aged. I don't know where I am. Person with, but muscle recovery becomes an increasingly part of longevity as you age, and so the idea that we could be on the cusp of finding a solution to that is pretty insane. Also insane, when it rains, it is an oldie time analogy that is not actually meant to be about rain, and it has nothing to do with the weather. It's about, troubles heaping up, I suppose.
Yep.
However, turns out, as an oldie time statement, it's absolutely correct in terms of how rain works. According to this study,
when it rains, you get wet.
Well, no, this you won't believe me. You're not. This is. I'm going to telegraph your disbelief. Half of the world's measured precipitation that falls in a year falls in 12 days. That's crazy. This is according to a new analysis of data collected over 16 years at weather stations across the planet Earth. They say also by century's end, climate models project that the lopsided distribution of rain and snow is likely to become more skewed, with half of annual precipitation falling in just 11 days instead of 12.
So, question. Does this mean 12 days, the same 12 days across the entire world are when this rain is happening? Or to say that in California, all of California's rain falls on 12 days? And
it would be half.
Or half, yeah. And in Arizona, half of their rain falls in 12 days, but it might be a different 12 days. You're saying it's the exact same 12 days around the world?
So it's globally.
It's a global average.
Average is 12 days.
Right, but it's okay. So the global average happens.
It could be a week in California. It could be 2 weeks in Arizona. But if you add it all up and look at the number of days and the amount of rain that fell, 12 days is half of it.
Interesting.
So I'll go into a little bit further detail here.
Yeah.
This is published in Geophysical Research Letters, which is a journal of the American Geophysical Union. Previous studies have shown that we can expect an increase in our extreme weather events. This is a global warming thing. weather patterns that are going to change. We're going to see more extreme drought, more extreme rains. This is a thing that's been predicted. Quotey voice of Angeline Pendergrass, scientist at the National Center for Atmospheric Research, lead author of the new study, and person also with an awesome name. This study shows how those two pieces fit together. We found what we found is that the expected increase happens when it's already the wettest. The rainiest day gets rainier. Findings suggest that flooding and the damage associated with it could also increase. Could have implications for water managers, urban planners, emergency responders. Research results are also a concern for agriculture because farmers like it to rain a little bit every day while the crops are growing, not just all at once and then stop, right?
Yeah, that's going to be an issue for like California and the west coast of the United States has been getting these atmospheric rivers over the last several years, and they're becoming more and more common where there's this, it is described as a river of high precipitation density that flows from the Pacific Ocean and then just drops itself when it hits the land. And these are, and the idea is that there are going to be more of these as climate change.
Right. And one of the points of Angeline Pendergrass is that definition of what qualifies as extreme precipitation. In some cases, we're so broad that extreme precipitation is actually the bulk of the precipitation. So at what point is that not the bulk, but the average, right? So, so if the extreme precipitation and the average precipitation are showing up in the same place, how do you make any sort of claim about what's extreme precipitation? Okay. So
it's already extreme.
Right. So she looked, Angeline Pendergrass looked to find a simpler, more intuitive framing of this concept that could be easily understood. In the end, she chose to quantify the number of days it would take for half of the year's precipitation to fall. And that's how she arrived at 12 days. I would have guessed the number would be larger, perhaps a month, said Angeline Pendergrass. But when we looked at the median or midpoint from all the available observation stations, the number was just 12 days. So that's a really wild and crazy and insane sort of thing for me.
For a big blue marble that is so much water. To have the water falling from the sky be limited to 12 days out of 365 seems shocking to me, for sure.
Well,
and
that's not how it is in Portland.
Well, right. So Portland is and this. So this is an average.
It's median.
Which is also it doesn't mean that everything where you are is going to follow this rule. For the analysis, Angeline Pendergrass worked with Rito Nuti of the Institute for Atmospheric and Climate Science in Zurich, Switzerland, and fellow awesomely named human. They used data from 185 ground stations over 16 years, 99 to 14, a period when measurements could be validated against data.
Kiki, you're muted.
Justin is dying again, and it's the opposite effect of what happens from all that rain over 12 days. It's the fires in California that are affecting him.
Yeah, so when you only get the rain over 12 days, then there's these periods of dry, and it's problematic.
It's problematic. Absolutely.
Anyway, that was a ridiculously insane statistic.
Yeah, that's crazy. And now everybody has something for trivia night.
Yeah.
New question for trivia night. I'm sure someone will use it somewhere. And as Fada says in the chat room, we now have the 12 days of wetness.
There you go.
Nice.
But as we move away from the rain, there are other things to think about, like Blair's Animal Corner.
Drugs are Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Let me tell you about wombat poop.
Please
Wombat
do.
poop.
I've always
Wombat
wondered.
poop is special. Kiki, why is wombat poop special?
It's special because it's a cube.
It's a cube. It's
Wait,
the only
what?
it's the only
Wait.
cube-shaped poop
What?
to our knowledge in the animal kingdom.
Right.
The
Cube scat.
How the
We can
What?
We don't send it to space, but it's a cube scat.
cube scat? Nice.
There you go.
Nicely done.
So,
how-
Justin, the how is exactly what we're talking about tonight.
Okay.
So, I have known that wombat poop is cube shaped for many, many years. There are hypotheses as to the why. The most likely is that it is helpful for them that their poop does not roll, since they live on a hilly terrain. So it helps them mark their territory. The poop stays where it lands because it is cube shaped. But until now, we did not know the how of this cube shaped poop. And for that, we turn to the Georgia Institute of Technology, not to a zoologist, but to a hydrodynamicist. So Patricia Yang studies hydrodynamics of fluids, and she wanted to figure this out. The only way to find out is to get up close and personal with what some might call the blunt end of a wombat. So they were shipped 2 euthanized roadkill wombats from Australia, and then they also had some pig specimens. And then she and her colleague, a mechanical engineer, quote, opened those intestines up like it was Christmas.
I don't know about that quote.
I don't either. I don't know what that
about
means,
that.
really.
I don't know why you would say that.
Like, was there a ribbon? It's anyway.
A
So
ribbon of small of smooth muscle.
intestine.
That's right.
Yeah, absolutely. So, the idea was, how in nature does this animal make cube-shaped poop? Now, first of all, as some might have guessed, it's not about their anus. Their anus is a normal, round-shaped one. So it's not like the Play-Doh effect where the shape of the opening is causing this cube shape. No. However, they did find out it's in the last 8% of the intestine that wombat waste turns into a solid cube. And this cube... Go ahead.
Is that the wombat colon?
Yeah. So the last 8% of the intestine, it turns into a solid cube. That shape is retained even after it goes through this round anus. So something is going on in the intestine that is not only making it cube shaped, but making it a well-preserved cube, because otherwise the push through might ruin that shape. So it would appear that this is a combination of 2 things. One, they eat a lot of dry food. Are you laughing at the number 2, Justin? And so they're really dry and compact droppings, which means that it retains its shape. If it was a very wet poop, as it is often in zoos, it is less cube-shaped because it doesn't retain its shape as well. So this dry, kind of desiccated poop is cube-shaped. But the second part, how it originally got cube-shaped, appears to have to do with the shape of their intestinal walls. There's variations in elasticity along the walls. And so the stretches of intestine, there's some of them where certain areas are less elastic and more stiff. And this creates sharp edges, resulting in a cube. So to explain a little bit better, pig intestine has uniform elasticity. So this is part of this fluid dynamic stuff, is that they push things through these intestines on a pig and on a wombat to see what would happen. So the pig intestine has uniform elasticity, which is why pig poop comes out round. But wombat intestines have an irregular shape, and they have 2 ravine-like grooves where it's stretchier, which allows kind of for this corner to form. But where that gets weird is that there's only 2. There's not 4 grooves. There's only 2. So how do 2 grooves make a cube? So it's still not clear. We have a good idea to the start of it. But the other thing that Yang says is we currently only have 2 methods to manufacture cubes. We mold it or we cut it. Now we have this 3rd method. So this finding, aside from clearing the air on this confusing thing that wombats do, they're the only ones, it gives us a good idea of how they're getting that done. It also, oddly enough, could potentially give us methodology to manufacture cube-shaped things out of soft materials.
So the first thing I thought is if those grooves are on opposite sides, they would sort of infer the other corners upon the structure.
Maybe.
But then the other thing that I thought was, yeah, why is it weird that there's cube poos, but not weird to me that there's round poos? Because like that also, I would assume, has to be formed before exiting. Otherwise,
Yeah.
I mean, I
Are you thinking about like giraffe and deer poop? That's like the perfect little
Logarithmic?
milk dud. Yeah.
It is weird that I mean, if you think about it from the not knowing that these things form before they escape, then you would assume everything would be logarithmic.
So for the thinking about kind of the milk dud poop, which I apologize for comparing to food, but we've talked about it on the show before. I would always kind of categorize the antelope poops by the different candy that they look. Anyway, so the milk dud poop it kind of makes perfect sense if you think about it, because as an animal that's a ruminant, that's kind of has a slow release of nutrients into the stomach from a foregut, right? Okay. So it's the kind of the constant drip of food into the back stomach before it enters the intestines. As it churns through the intestines, it's going to make the most compact shape it can, which is a sphere. So that kind of makes sense if you think about that. When you think about carnivores, they have the log poops because they're eating all at once. They eat in one big group. It drops down to the stomach. It comes out all at once.
Also, I want to point out that the word poop is the most performative in the English language. It starts puckered, it opens up, and then it puckers again at the end.
Are you saying it's an automatopoeia?
Yeah.
Poop.
Visual and auditory.
Yeah,
it's a performative. It's a performative word.
Yeah, there you go.
Unlike
I like it. I like it.
I love the idea that someday we'll be using technology based on wombat intestines. For building materials. This could be good. This could be good. I see a wombat Play-Doh Christmas present coming.
Yes.
Oh my God,
how do you think Legos are made?
Yeah. There you go.
Just saying, nobody knows that
nobody
it might
knows.
be wombat.
That's
can't be a plastic mold. Okay,
Tell
and
me more stories.
My next story is from Portland State University. Ayo.
Wait, which Portland?
Portland, Oregon.
Portland, Oregon.
Yes.
Oh, okay.
Portland University looking at vitamin D and its role in fetal development. So vitamin D, we know that vitamin D is essential to the regulation of calcium. We know that it's critical to life history transitions. There's lots of things that vitamin D does, but there's a new thing that we know about, and this is about triggering embryonic development, and in this case, in a species of fish. So there's a killifish Ostrofundulus limnaeus, which lives its entire life in seasonal ponds. Because the seasonal pond, that means when it rains, it fills, and then when it evaporates, the fish will kind of go into the mud. If they've already laid eggs, the embryos in those eggs will develop along two distinct trajectories. One, the embryo grows if it's wet, but if it dried out, then two, the embryo will enter dormancy, during which all development stops, and that allows embryos to survive for months in this drying mud without oxygen or water. And then once it fills up again, bam, they're off to the races. They're developing once again. So this study wanted to know what regulated dormancy in this fish and what mechanisms provided for the integration of environmental cues to make all this happen, right? So they simulated environmental conditions with these killifish at different temperatures. And so they had their two different trajectories. And then they analyzed fish RNA during different developmental stages, looking for genes that express that the expression triggered development. So which gene is triggering the development along each trajectory. And what they found was that vitamin D synthesis and signaling promoted normal development under environmental conditions that favored dormancy, and inhibiting the vitamin D synthesis pathway resulted in dormancy under conditions that would normally favor development. So by messing with vitamin D synthesis, the genes that do that, they were able to make the embryos do the opposite of what environmental cues were telling them. So the vitamin D appear to be the signal. The vitamin D was the signal that was telling them grow, don't grow. So they were also, this is where this gets crazy for me though. So, okay, great. This fish that normally does dormancy, it's the vitamin D that's doing it, it would appear. But then they took zebrafish. Zebrafish do not suspend embryonic development. And by blocking vitamin D synthesis, they induced dormancy in zebrafish.
What?
Yes.
Ooh.
Then, looking further, they found similar receptors regulating dormancy in roundworms and fruit flies.
Whoa.
So not only does vitamin D create kind of the domino effect of dormancy in fetal development in a vertebrate that doesn't normally do that, but this signaling pathway exists all the way back to roundworms and fruit flies and other invertebrates. So this looks...
When you say all the way back,
yes,
you have to point out that these life forms are just as evolved.
Yes.
As
okay. So we're talking about...
We're talking about a conserved trait.
This is a conserved trait. This is a conserved signaling pathway. So
it's useful.
So this is, it would be extremely unlikely that this is some sort of convergent evolution. This appears to be something way, 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 way back in the building blocks of life. So this appears to be something that has been conserved across species, across groups of species, long across evolutionary history. And so this is the sci-fi part. This fits in really well with kind of the theme of our show today, is that this potentially has the ability to be used to induce dormancy in species of fish that do not normally have dormancy, in other species that don't have dormancy, and maybe even humans, something that was once considered impossible, of course. So this is something that if it was this well conserved, it's possible that you could kind of step it up the evolutionary tree further and further and further. Would this work in an amphibian? Would this work in a reptile? Would this work in a bird? Would this work in a mammal? It's possible. Go ahead.
Looking at this pathway, I mean, what we're talking about is a developmental pathway in the killifish and the zebrafish. So it's not like you could be like, hey, fully grown human right away, let me mess up this pathway.
Right.
But what they're talking about is this at the molecular level. What can you do to make molecular pathways just kind of stop for a while without killing the cell, right? And if you can do that at the level of the cell, can you do it at the level of the organism? And so maybe someday down the road, adult human, let's put you in stasis while you travel from, travel between star systems, possibly. Or maybe it'll be a better way to put embryos on stasis for people who want to save them till pregnancy would be easier for them.
Yeah, or if you're diagnosed with some illness while you're pregnant, you could put your pregnancy on hold while it gets cured. So
by today's standards, there's no way to cure this awful disease or traumatic injury that you have. Click. Okay, we'll get back to that one once we've figured that out.
Yeah. So the other thing that this reminded me of, though, is that there is something kind of like this in mammals. It's in marsupials. So back to the wombats again. Marsupials are crazy. Like, they do all sorts of crazy things. But one thing that marsupials, particularly kangaroos, are famous for doing is embryonic diapause, which involves putting an embryo on hold in your body. So there is kind of this precedence for something like this happening in mammals. Not to mention, snakes can have fertilized eggs in their bodies, and they can let those go dormant for
a lot of
years.
Yeah.
So I would be interested to see if there's any sort of link between these things, because it's not totally unheard of.
Yeah. I'd love to find out. And it's interesting. This is a really interesting role for vitamin D. Beyond just the get your sunshine kind of thing. It's very it's interesting.
Yeah.
I wonder, this is probably, development tied in with circadian rhythms, tied in with melatonin, which is also tied up with vitamin D. And, and then from Justin's story earlier about the timing of the treatment to the muscle and how it didn't necessarily work all the time in the old muscle, that maybe there are other factors at play related to things like vitamin D and circadian rhythms. So
and
interesting stuff there.
The thing that occurred to me is, like, this could be in the future, instead of plan B, it would be plan D, which is like I'm not going to say no to this.
Just not yet.
Not yet.
Yeah.
Right.
I got a schedule laid out this year. Next year I can free stuff out. I'll be out of school, or I'll be in a better place where I want to see exactly how they turn out. Like, there's a lot of hanging possibility contingencies here. Plan D. We'll just put it on plan D.
Plan D.
Just not now.
I've got a couple of quick stories.
Yeah.
We are at the end of the show. I'd love to roll us forward. We have talked so many times on the show about the amazing strength of spider silk.
Yes.
And how it is stronger than steel, yet at the same time can be flexible and dynamic. What is the cause of this? Well, researchers just published in ACS Macro Letters a study in which they have looked at the nanostructure of spider silk. And there's the idea that nanofibers that make up that there are little tiny nanofibers that make up spider silk. But nobody's been ever to see it before. And they looked, and yes, indeed, they looked at the sticky, wonderful silk of the brown recluse spider, also known for giving necrotizing bites that are horrific. But its silk is fantastic, and its silk, unlike other spiders, is a flat ribbon. It's kind of like, it's like a printer cable, a flat ribbon, as opposed to a cylindrical fiber.
That was a fantastic analogy.
Yeah, and so it was also easier to look at under a microscope. And when they looked, what they found is that each strand of spider silk, 1,000 times thinner than a human hair, is made up of thousands of nanostrands. 20 millionths of a millimeter in diameter.
Wow.
And so each fiber of this spider silk is made up of parallel nanostrands, and each of them is at least 1 micron long. But then that's 1 micron is about 50 times longer than the fibers are wide. And so they can stretch and they can connect to each other and they create incredibly strong silk. And this could potentially lead to the first thing I thought of, hey, sci-fi, carbon nanotubes to make the space elevator cable that we're trying to do. You know, how can we put that together from the nanoscale in a similar way to spider silk?
Yeah, and the first thing that's how you make rope.
That's how you make rope. Yes, parallel strands,
so,
right?
like,
Weave them together.
Well, but there's
no,
rope
it's individual
has, like,
small
twisting, right?
strands run together, make the rope thing itself as strong.
But
and
this is like
robust and
flat, right? This is not.
This
I mean,
particular spider has a flat cable, but
ribbon.
it's
That's so
a
interesting.
flat
Which is
ribbon.
described as printer cable, which I got immediately, and also realized that like 90% of our audience probably
Yeah.
didn't.
No,
because
I was
it
thinking
hasn't
that
been
too.
flat ribbon cable.
I definitely
in
got it.
forever. But
Yeah.
I would have gotten ribbon candy, which predated printer ribbon cables. So like, we're too old to explain this in what a ribbon is. Anyway,
in a way that. Anyhow,
it just made that's an intuitive. It's fantastic because it's intuitive at the smaller scale. The thing that worked at the large scale of how we made rope from hemp or whatever is the same way that spiders make their silk.
Yeah, that's very cool.
That's cool.
Yep, flat parallel ribbons, little tiny cables. Maybe I honestly think this is going to help us make the space elevator. This is what we need.
That's great.
Thank you, spiders.
But should we?
But should we? Yes. And then my final story has to do with rare microbes. These microbes were first discovered in the 19th century. However, a recent hike by a graduate student in which she collected some. Her name is Jana Eglet at Dalhousie University in Nova Scotia. She collected some dirt on a hike, just like, I'll just take some dirt back to the lab. She likes the things in dirt. She wanted to see what would grow. And while expecting the normal protists and diatoms, she found some protists that she wasn't expecting. She saw some little flagellid creatures. They had little single-celled organisms that had lots of flagella, little hairs all around them. However, they didn't seem to know how to use their hairs in a coordinated fashion. And she was like, what are these? And she just determined that they were of a class of organisms discovered in the 19th century called hemimastigotes. And it turns out these hemimastigotes have never been classified, really. They've kind of been thrown in the general protists. They just were given a species of phyla. They're just kind of in there. However, nobody has ever done molecular taxonomy on these organisms. And so she and another graduate student said, hey, it's time to run the genetic analysis. And they looked into these hemimastigotes, determining that they are their very own branch of life.
Wow.
That they are a domain of organisms, eukaryotic organisms that are not bacteria, are not archaea, and that are different.
Burn all the biology books. Start over.
Wow. No, but this is like
a
the
new branch
of discovery possible at this point. Like, this is wild.
It's absolutely wild in these little organisms.
That's dang near alien life on the planet when you look at it that way, compared to the known life.
Eglet says it's extremely exciting that it's possible to discover something so different from all known life on Earth. It really shows how much more there is out there. But other researchers noted that the other researcher noted that discoveries like this one are pretty rare, and it'll be the one time in my lifetime that we find this sort of thing.
Yeah, in many lifetimes.
Yeah, so they are their own supra kingdom They're
Oh.
a grouping so big that animals and fungi, which have their own kingdoms, are considered similar enough to be part of the same super kingdom. And so these organisms, these hemimastigotes, are unique and different enough from other organisms to be their own supra kingdom.
That's insane.
Wow.
Yeah, just from a whim. I'm going to collect dirt and let's do this project.
Yeah. So sample. And then
Yeah.
sample again, and then sample from the sample and sample some more. Like this
Yep.
is how you do these things, people.
Yeah. Blair, did you have one more story?
Oh, yes, a very quick, fun one. We have rings in our teeth, just like rings on a tree. And those rings tell a story. A piece of research from 4 different universities in Tokyo working together, looking at black bears in the wild, 13 female black bears being monitored from 2002 to 2017. They were able to follow their life history and then pull out a single tooth, one that hopefully would not bother them at all, the first premolar, not used for eating. They looked at the tooth and looked at the layers of the cementum annuli, and the width tells them whether that female bear had cubs that year or not. A thinner layer means they were using all of their nutrients to grow and then feed cubs. And so they can tell just by looking at this one molar a lot about the life of a bear.
If you're building bones for another life form, you don't have as much to spend on your teeth.
Yeah. And so this is something that probably is can pretty easily be extrapolated to pretty much anything with teeth. So there's a lot of potential here for further research.
That's neat. Yeah, I can imagine the way you could look at that to determine individual histories on fossilized humans, on Paleolithic people, on
So we could go back in time and say, like, how many kids on average did people have in the Paleolithic era by just looking at their teeth? That's fascinating.
Yeah.
That's cool.
Yeah, it would definitely work, on animals that have their babies in their body while they're developing. So reptiles and others that produce offspring in eggs externally, it's not going to have the same
So
effect.
that depends because it's possible
For the
that
shell?
the shell,
You have to
the creation of a shell. So then if it's
also, you have to you have to. I mean, I'm sorry, but you would have to do all of your donations up front, perhaps,
right,
to this new life form.
Yeah.
For it to have the components it needs to develop these things. And it may even be more of an extreme example, but I would love to see.
Yeah. Yeah, that's really the question, is how far does this go? Because one can guess it probably works with most mammals just in general, because they have to give milk to their babies. But anything else past that, possible that the eggs creation of egg case is enough. It's also possible it's not. So it depends. And then if you're the kind of snake that reabsorbs eggs before you give a live birth, does it show up at all? Maybe not. Maybe still it does.
That's a thing?
Yes.
Wait, stop.
Yeah.
That's a thing?
Yes.
A snake reabsorbs an egg that it already made and then gives live birth?
Yeah, it's ovoviviparous. Yes. So most boas, lots of sharks, reabsorb the egg in the birth canal before they give then live birth. Yes.
So that's a totally indecisive birth scenario. Like, I had no idea that existed.
Yeah.
How come we should talk sometime about all the things that exist?
Ask your neighborhood zookeeper.
That's right.
That's
oh my
crazy.
goodness.
That's an awesome example of evolution right there. I've ever heard of it.
There you go.
Thank you for blowing Justin's mind, and probably
Totally just
one of our listeners
right at the end of the show.
Right at the end of the show. We'll just leave you all on that. Have a wonderful TWISGiving, everyone. Like the milk, we give you the science. I don't know if that worked. That didn't work.
I'm good. I'm following it.
My teeth are always a little thinner on Wednesday night. Is that what you're trying to say?
Yeah, that's right. Anyhow, thank you so much for enjoying the show with us. We hope you enjoyed all of it. Our TWIS calendars are now available for order. If you are interested in learning more, please visit TWIS.org. TWIS.org. And many, many thanks to all of you as we head into the American Day of Giving Thanks. Shout outs to Fada, Identity 4, Gord McLeod, the chat room, all you viewers on YouTube, chatting it up over there, and our Patreon sponsors. I want to take a moment to say thank you to those Patreon sponsors. Thank you to Paul Disney, Richard Onimus, Ed Dyer, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeBell, Alex Wilson, Tony Steele, Craig Landon, John Ratnaswamy, Mark Mazzaros, Jack Matthew Lipwin, Jason Roberts, Bill K, Bug Calder, Time Jumper 319, Eric Knapp, Richard Brian Condren, Dave Neighbor, Aiden Jeff, Corinne Benton, Sue Doster, Paul Ronovich, Dave Wilkinson, Ben Bignell, Richard Porter, Jacqueline Boyster, Noodles, Kevin Reardon, Christoph Zuknarek, Ashish Pants, Ulysses Adkins, Sarah Chavis, Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazewski, Jim Drapeau, Greg Riley, Sean Lamb, Ben Rothig, Steve Lesseman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, E.O. Thank you for all of your support on Patreon. And if you are interested in supporting us, you can find information at TWIS.org and click on the Patreon button and any number of things over there. And remember that you can also help us out simply by telling your friends about TWIS. On next week's show, we have another interview, next time with Alexander Himmel. Dr. Himmel is from Fermilab, and he's going to talk to us about Proto-Dune, the deep underground neutrino
Another
experiment.
Fermilab.
What? Fermilab in the house or in the podcast. And we will be broadcasting live online at 8 p.m. Pacific time next Wednesday on twis.org/live. You can watch and join our chat room. You can also do the same on our YouTube channel. Just look for This Week in Science or look for twis.org. There we go.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory. Or if you have one of the mobile type devices that are now available, you can look for TWIS, the number 4 Droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's right. You remember, it's www.twis.org. While you're there, make comments and start conversations with the hosts or other listeners.
Contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just put TWIS, TWIS, somewhere in your subject line. Otherwise, your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you tonight, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
That does it, eh? Is that it, eh? We doozed it. We did another show.
We do's done darn did it.
Yeah. Darn tootin'. Hey, everybody. I'm going to stop that screen sharing now, although I'm trying to get you to go to TWIS.org and buy our calendars, please. I try and be I try and make my wording very non-commercial during the show, so I have less editing when it comes to the radio show later, because I'd love our radio show listeners to also know about the calendar, but the radio goes out to non-commercial stations, and so
Right.
being non-commercial, you have to not have calls to action and all that kind of stuff. So it's like, so we've got this calendar, and if you want to find out about it, you can go to this link if you want to learn more.
Yeah.
No, but I can't tell anybody to do anything. And guys, buy our calendar. Now I can say whatever I want.
I have at least, I think, 5 like word of mouth orders from people who are like, I'm not gonna make an order online, but just bring them to me. Okay.
Okay. I may be having a late end of the year trip if people don't mind. I mean, I'll probably just mail them to you, but I could bring some down possibly in luggage if people don't
That'd
mind
be fun. Yeah.
getting it at the very end of the year, like for a New Year's present or something. Yeah. Yeah, Fada, that's what I'm saying there. What else do we want? Thanks everybody for watching. We're glad that you're here. We're glad you're here with us. I met so many people at ThinkerCon last week. Oh my gosh, so many YouTubers. So many YouTubers. It was a very
That's
YouTube.
fun.
Yeah, it was a very YouTube heavy event.
That's cool.
I felt old.
Mhm.
I hung out with several of the older people most of the time, but then I met some
That's
younger people.
that's exactly what I thought of when you were talking to me about that. I was like, oh, I would feel old at a YouTube event for sure.
Yeah, it was very YouTubey. And there, obviously there were lots of 20 somethings who were
Mhm.
extremely enthusiastic and, um, young, full of
Yeah.
vim and vigor. And yes, and yeah. So
When I
it
went
was
to
very interesting.
what was it called? Podfest? No, what was it? Well,
Did you go to Podfest?
what was it called? Oh, the one at Fort Worth when
The pod something.
Pod something.
Yes.
It was a podcast conference. Oh gosh, that's gonna kill me. Anyway, when I went there, it wasn't so much a bunch of young people, but it was a bunch of
Mhm.
people talking like they were 22 years old.
Oh,
Because
that's
they were
funny.
like, it was just stuff like, oh well, yeah, I just quit my job and I'm really looking to make my podcast be my full-time gig, and I have about a month of funds, and I think it'll be fine. And every time I was just kind of like, is it too late to go back to your job?
I know.
So the thing about podcasting though is success in podcasting. I'll just give you all the clue right now. The hint, the inside scoop
Mhm.
is that the to be successful, you have to do two things. One, you have to pick a thing that is geographically and non-geographically appealing to the largest number of possible people, which we
Mhm.
didn't do. And two, you have to lower your standards for your expectation of success.
Yeah.
Those two things will make you successful.
Oh, I was gonna say 3, start 20 years ago. 4, find advertisers and keep them, which is very hard to do.
I forgot a third thing, which is already be successful and famous.
Yeah. Oh yeah,
That
5.
also helps.
Yeah.
That also helps.
That does
be
help.
extremely successfully famous
Mhm.
and influential already before you. It's sort of like writing a book. Like a lot of people are probably really good book writers. One of the last books I bought was what the heck is it called? Higher Calling, James Comey. And if you could be a better writer than James Comey, but you weren't a former head of the FBI with a history. And so I wasn't already immediately interested in your story before I could tell whether or not you could tell your story well. Right. So there is like that aspect to it, which by the way, that's a pretty good read. It's got a pretty decent insight and sense of humor about some things in the world.
Yeah, but it's the coming out of nowhere. That those are the true success stories, the people who come out of nowhere and come and, do something brilliant. and
Name
become
two. Name one.
J.K. Rowling?
Well, okay. But I would say J.K. Rowling.
You asked me to name somebody.
No.
Come on.
Very, very well done. But J.K. Rowling's story is interesting in that J.K. Rowling's story was a very long story of rejection after rejection after rejection after rejection.
But
it is actually probably one of the biggest stories of how to weather massive rejection before finally getting acknowledged and becoming a superstar. So I mean, in the coming out of nowhere scenario, it comes with also the having the ability to weather massive continuous amounts of rejection for a very long time.
Yeah.
For most people.
So I bought my podcasting mic. I've done an episode and I quit my job because this is going to be my full-time job from here forward. I have a month of savings. Not the best plan.
But yeah,
Unless
it works out.
they are a brilliant marketer and they have hit on the thing that is really going to be very popular to people. And
Or if you live with your mother.
exactly.
Right. If you don't have bills,
It's
then
fine. It's fine.
that job. So okay. So this is something sort of
Married
interesting 'cause
wealthy. That's another option.
this came up yesterday. Very good friend of mine. He called it a midlife crisis, but I just actually looked at it as the logical next step in a history of having done things in the past. But he quit his regular jobs to start his own company. And this is something we will end up talking about in the future. Currently got a show with Showtime that'll probably be launching the actual episodes of a TV show next year, having to do with couples in therapy, documentary stuff. But this is somebody who took a huge leap from what they were doing to what they're now doing.
Yeah.
I kind of did a little bit of this myself in the last year. I
Yeah.
completely changed career trajectory,
which is
stuff.
awesome.
Yeah, but
awesome.
I understand that urge and desire to chuck it all and do the thing that's the ideal and the passion.
I think my issue with the kind of the reason that I think it's kind of silly, this narrative in particular, is that podcasting doesn't really have a clear revenue stream. Like even people that are successful podcasters, they do other things to fund their podcast.
Yeah, and but there is an aspect of this because as long as there's been podcasts, it's still relatively in its infancy. The one thing that I this occurred to me during this conversation was professional athletes in the name the sport. Okay. Is as much as we're wowed by the multi-million-dollar seemingly short year contracts of elite athletes today, there were generations of athletes who dedicated their lives to sport, who didn't really who had side jobs, who had to have a job whenever they weren't in the NFL playing as the star quarterback or whatever the heck it was, right? Or baseball or NBA or whatever. These are people who had regular jobs and it's oh, what are you doing this weekend? Got a football game. Yeah, I'm gonna go out there with some friends of mine. It's this thing we do, right? So yeah, these people who are willing to switch their careers to podcasting do have to hopefully realize that it is in its infancy.
Well, that's exactly my point, right? I'm not going to say I'm going to quit my job and go do mini golf full time because it's not a revenue stream right now.
Unless,
maybe in 30 years it will be. Who knows?
If you YouTube it, you may find that there's actually a following for somebody who is an avid daily mini golfer who's giving you the tip of the day.
Right.
That could end up being a thing. Somebody might want to look into this.
Go mini golfing.
But you don't quit your job to do it is the point, right?
You do it on the weekends, the evenings, the holidays.
It depends on what it is. There's people on the interwebs who will play video games who have magnitudes more followers, subscribers, what have you, than we have accumulated in mass over the many years of podcasting science news. There's things more popular than science news this week, apparently. I don't know why. It seems ridiculous to me that there should be anything else that people would be tuned into but this show. But,
for example, makeup tutorials on YouTube. Very popular.
Do you know who's really into that? My 5-year-old. My 5-year-old.
Really?
She will watch these weird makeup shows. And I'm like, what are you doing? She's just fascinated by the transformation.
Oh my God.
The before and after.
That's
stuff.
great. I love that.
And also, she watches some show with like Japanese kids playing with like lawn toys. I'm not really sure.
Huh.
It's in Japanese too. It's not even like there's no translation effort
Yeah,
made.
maybe
And
she's
she's
learning.
really into some eclectic
Yeah.
things.
Yeah.
Fascinating. She'll be a geisha.
Yeah.
She's actually, this one's most likely going to be like a ninja hired
Yeah, I was
assassin.
gonna say maybe,
There we
maybe
go.
she's watching
little
all
on
of
the
the makeup
fierce side.
tutorials to get good at like monster makeup.
Oh, yeah.
Camouflage.
She is a big Halloween fan. This is true.
Yeah.
That's good. Let's see. What was I thinking in terms
You didn't
of?
tell us, so we can't help you. If you
I
tell us what you're thinking, like I do, have
know.
you noticed? If I'm thinking something, I tell you right away.
Right
I
away.
don't hesitate.
Comes
I don't
right
give
out.
myself an opportunity to forget it. I just say it right away. Maybe I won't get back to it again because I interjected too soon. It might be a half hour later before I get around to it. But I tell you right away. So at least you could possibly remind me of what it was I was going to tell
Oh
you.
my
Because
God.
I
This is
uttered
like my son. This is like my son. My son, he talks all the time, and we were driving from Redmond, Oregon back to Portland, and it was like a 3-hour drive, and he's just chattering away from the back seat, and we for a moment we're like, can we have a little quiet for just a little bit? And he's like, Mommy, but I need to get it out because I might forget it. I need to say it because I might forget it. Okay. All right. Well, maybe it's okay. You can forget it for just a little while. Okay. It's okay.
It won't come back, and I won't care later.
You
This is also
won't care.
the thing about talking in the now. It's like there's a good chance I'm not going to care about saying this later. This is why I have to say it now.
That's
Get it out of
right.
the way.
Talking to
I
Jeff
might not even agree with it 5 minutes from now.
into the brain of a 7-year-old. Is that what we're learning?
That's it. Calendars are ordered. They are on the way. So they are real. They will be real
That's great.
in about a week. They will be
Nice.
real.
Can't wait.
Yeah. I can't wait either. It'll be just great to get them and be able to look at them and be able to flash them up here. It's like,
Yeah.
calendars, you people. Calendars. Get your calendars. 700th episode
Yes.
is coming.
Yes.
And there's birthday episode. Birthday episode will be a fun, just birthday. It'll be a birthday. But the episode after that, episode on the 19th of December, is going to be our 700th episode. Should we just do a normal episode? What should episode 700 be? Should there
Well,
be?
do you want to fly me to Portland?
Come to Portland. Well, I'll hang out in the studio together.
Yeah. Are we
Right.
Are we dressing fancy? Should I put on my bow tie?
I know, right? Get some fancy hair.
Yeah.
Get a rhinestone tiara.
Should we maybe let's just have an extended what has science done for me lately, and each of us can say something?
Oh.
We could do that.
That'd be a
I
nice
like that.
thing.
Everyone in the chat room, 700. What should we do? Do you have ideas from past episodes? Is there, Turkey Identity 4, Turkey Identity 4, 7 weird science stories. Yes, weird science. What should we do? What should we do? We have a few episodes still in between then and now. Yeah, welcome to the 700 Club.
Uh-oh. Isn't that the name of that weird TV show?
Yeah, it's a evangelical thing.
Yeah.
With Pat, what's his name?
I don't know. I just remember it always came on after, gosh, I think it was The Price is Right.
Pat Robertson.
When I was like homesick from school and watching The Price is Right. I think it was the 700 Club always came on after. I was like, oh man, give me my game shows.
So Wikipedia describes it. Let's see. Is that Wikipedia? I don't know. 700 Club is a talk show featuring guests, news, and spiritual stories from a Christian perspective.
Mhm.
News stories are often related to Bible passages. And so basically, we could do our 700 Club talk show featuring guests, news, and science stories from a science perspective.
Yeah.
And have news stories that are related to science,
Yes.
which doesn't really make it any different from any other episode.
Yeah, that would be. I think we should do it with all of the science stories related to biblical passages. We should we should tie the Bible into each of the science stories that we do.
Or not.
I think it could be fun. I think it'd be a challenge. I think it'd be like an extra level of difficulty.
Turkey Identity
Like
4.
hurdles.
Noodles says no, just 700 poops. Turkey Identity 4 says, let's have nothing to do with him and his TV show. That's right. Yeah, our 700 club will be pretty awesome. Oh, Pam wants us to shoot 700 in Australia.
Oh, yeah.
I'll just do that.
Yeah.
Just get tickets right now. Let's do it.
How soon is this?
It would be amazing.
In a month?
I would love to get a trip to Australia.
Yeah, can we work on that?
Yeah. Okay. Science life goals for TWIS.
Yeah.
A trip to CERN.
Yep. Mm-hmm.
Be nice.
To go to the LHC. Huh?
Then TWIS goes down under.
And then, yes, and then we go to Australia and New Zealand, of course. Yeah.
Yeah, it would. Ooh,
That's just
and then there's Science Island.
I would want to. If we went to Australia and New Zealand, I would say we should do like a 3-week trip and do like 3 different live shows in 3 different places, right? During that time. And then in other ways, just like document our travels around Australia and New Zealand.
Mm-hmm.
Let's make it happen.
Yeah. Daniel Foland in YouTube said, and on the 7th day, the wombat rested.
Yes, that's true.
And there were no more square poops. Yeah. And Pam, stop rubbing in all your wonderful travels. It's like everything I say, she's like, oh, I've been to CERN. Oh, I've done that. It's amazing. Of course it was.
But to be fair,
amazing.
Pamela is one of the rare humans, a type of human that I used to be when I was her age.
But she's as old as we are. She's almost.
No.
She's like 5 years younger. She's like,
it's a lot now. It used to not be a big number. Now it seems like a lot.
Maybe not as old, not quite as old. Whatever.
Pam's built herself for travel.
I know. She's an amazing traveler. Yeah.
Yeah.
Yep. Turkey Identity 4. Yeah, see, I knew it. Turkey Identity 4 says, so was the Minecraft universe pooped out by a cosmic wombat?
Yeah.
All those cubes.
All those pixels.
That's right. That's right. Oh my goodness. If we went to Oz, at least one of the hosts would be eaten. Thanks, Ben. Who's betting on who it'll be?
Oh,
not me.
Me, for sure.
Because I am not going to be anywhere near anything that's alive.
Yeah. Then you're
like,
it sounds like.
The hotel bar looks good from here. I'll see you guys. You're going to go out and meet the wildlife of Australia. Okay, talk to you in a couple hours. I'll be over here.
I follow this Instagram account. I think it's her name is wannabe entomologist, and she posts videos and pictures of all of her spiders that she finds. But it's Australian spiders, so she'll like be there with like a huntsman spider with its big fangs on her hand, and she's got these giant spiders, and she's like, oh, isn't this wonderful? And she writes this nice little thing and about this lovely little spider and blah, 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 blah. And I'm like, and so it's like my daily dose of, I
So
love it. It's a great
let's
account.
do a little prep.
He
we're
promotes
gonna go
love
to
of spiders, and so I'm working myself into it.
I need the two of you to repeat after me.
What? No.
We're gonna learn how to speak Australian. Ready?
No, you've
right.
done this before. I'm not gonna do it. I'm not gonna
Just
do
repeat
it.
after me. Just follow along.
Lights.
Thing. Huh?
Lights.
Raise
Yeah,
up.
raise up lights.
Raise up. Yeah, that's what we'll need to
up the lights.
shave.
Yeah,
We'll
we've
need
done.
raise up lights.
Yeah.
Okay. All right. I guess I told all my jokes. Good night, everybody.
No. So Pam's near the beach and she's invited us to come over. I love that.
Oh, good.
But we can't swim at her beach.
Can we
because
stay with you, Pam?
Big
We
white
have to
sharks
cut down
circling
the
around.
budget a little bit. Can we stay with you?
I love that in the next set. She's like, come to the beach, hang out. I live by the beach. You can't swim there. You'll die.
Yeah. Is it the sharks or is it the undertow? Which is it?
The undertow just takes you out to the sharks. Isn't that why the undertow is bad?
Probably like deadly jellyfish and
Jellyfish.
sharks,
Yeah, yeah.
all the things. Let's see. If
The only thing preventing me from going to Australia and coming back is the 30 hours of my life on a plane that I would.
Oh
never
yeah,
get back.
30. Yeah.
Okay, so it's not sharks, it's crocs, jellyfish and crocs.
Oh yes,
In the ocean.
Yeah. Saltwater crocodiles swim from Australia to Africa.
What?
And they come back again?
Yes. Saltwater crocodiles can cross the ocean.
My God.
Oh my God. Yeah, I don't want to go in your
part
water,
of the planet where
Pam.
they haven't gotten rid of the super predators already.
Irukanji.
Oh, and bull sharks. Oh my God.
That's Ben adding that. Oh my goodness. Let's see. So if we look up 700 on Wikipedia,
Just the number 700?
just the number 700. 700 was a leap year starting on Thursday of the Julian calendar. The 700th year of the Common Era, and Anno Domini designations, the 700th year of the first millennium. Blah blah bloop blah blah bloop. Any other 700 interesting things? I like looking up. Maybe there's some kind of theme.
Hmm.
Right.
This is
While
just
you're
like
doing that,
year
I'm going to
700.
just simply Google it.
Yeah, if anybody has ideas what we should do on our 700th episode, let me know. I'm thinking about it. Yes, so life goals, CERN, LHC, Australia, do science podcasts and travels would be amazing. I like this idea. I love this idea.
Oh,
Somebody
according
would
to
like to
Google,
pay for it.
700, this is interesting. 700 is the natural number following 699 and preceding 701.
Oh,
Thank you.
I did not know that. That's pretty interesting.
yeah. That's good. See how you can use that in your disclaimer.
I don't know. Anyway, yeah, so I think that's it coming up. There, 12 hours each way on the plane. You forgot the with Jackson fly, Pam.
Yeah.
Not just Jackson
Oh
fly,
no,
but
Justin.
with
Oh
Jackson fly.
shoot, they didn't seat us together.
Wait, what? Why is it? Wait, how is? I don't even know why this is funny. Like, I need to now know why this is funny because I didn't even know. Okay, first of all, I cannot sleep on a plane. So I know, Blair, for a fact, because I have sat next to you on long flights, that you were not the least bit bothered by me because you're
Sleeping.
snoring the entire trip.
Yeah.
We're gone. You got the eye sleep thing. You got the earbuds in, and
Tylenol PM.
you're sleeping. You're unconscious in the lap of the gentleman next to us, and meanwhile I'm like, they're coming around again with more drinks and peanuts because I'm still wide awake, and I don't know why. At whatever time it is, like, yeah.
Oh yeah, Pam, I don't care about a 12-hour flight. I did 14 to get to Israel. 4 times, 3 times.
You were awake for an hour of it at most.
No, actually, I was awake for like 8 hours of it. Yeah, it's a lot. It's
a lot.
3 of the 4 times I did it, I was in charge of 40 other people on the plane, so like I couldn't actually sleep all the way. So it was a whole
I
thing.
feel like once you're on the plane, they're not your responsibility anymore.
Oh, they definitely are, because they weren't allowed to order booze, so I had to make sure they didn't do that. A few of them were like scared of flying, so I had to like talk to them multiple times during the flight.
Talk you down.
Yeah.
Don't worry about the flight. Everything is going to be fine. The chances that somebody brought a bomb on this plane is 1 in a billion. And you know what? The chances of 2 people bringing bombs is 1 in 984 billion. So just to be safe, I brought the bomb. We're going to be fine.
Good. And then Justin was never let on a plane
ever again.
Well, you got to play the odds, and I was trying to explain the reason I brought a bomb on the plane is because the chances of 2 people, they didn't like the answer. Banned from international travel because I tried to be safe, which is really unfortunate.
Yes. I think it's time to go rest. Rest so that you'll be ready to digest tomorrow.
Yep.
Yeah, it's actually odd that this, I think, is the very first TWISGiving episode where we didn't talk about L-tryptophan or turkey digestion.
It's true.
During the episode. Like that's like a common theme. Like there's always a timely insight into something about.
But we did talk about poop. So
we did.
You know what? I hadn't put that together.
Risk and poop.
They're like, I'm just gonna go make a couple of cubes, make room. I'll be back.
Risk and innovation with regards to how you address conversation around your Thanksgiving dinner table.
Speaking of risk, this is the last thing I heard this evening. I have known my entire life that I have no risk aversion to heights. Climb the tall tree, be up on a very high precipice, whatever. I've never had any fear whatsoever of being in high places. And there's been an update to the 23andMe, and one of the things in this massive traits is it was like less likely than the average to be afraid of heights. And I thought, wow, how insane is that my lack of fear of heights could be genetic?
Jeez.
That was insane. Yeah. And then the other aspect was less likely than most to like the taste of cilantro. And
I have that one.
And I had that, which is totally true. Like the littlest bit of cilantro, I'm like, why is this here? This is a horrible thing.
It tastes like soap.
No, exactly. And they point this out in the thing, and I was like, yeah, that's why it's like so weird that somebody would put this in food. But those were two little newly added elements to the 23andMe thing that when I saw, I immediately was like, wow, that really fits. The other one, there was a third one, which pointed out that I have the genetics common amongst elite athletes. Yeah. And so I but what it comes down to is with my elite genes, which I now know that I have, is what they really confer to an elite athlete would be the difference of about 2 to 3% in performance. Meaning if you are somebody who's trained as an athlete all of your life and aggressively, but you lack this gene, you'll be 2 to 3% behind the elite athlete who has this gene.
What if you had trained?
I would have the 97%.
What if you had trained?
Effort to put in to get to the point or that elite athletic gene meant anything. I'd still have to put in the other 97% of work. So I was like a little disappointed because I was like, I saw athlete gene. I'm like, I'm an elite athlete. But then I realized, yeah, I'd have to put in 97% more work than I do now for that to actually be noticeable.
Yeah, just start running right now. Let's just get those
And they also added
exercise.
some new graphics to the ancestry portion, which is sort of interesting. Whereas before it would tell you you're part this, you're part that, you're from over here, you're from over there, you got this, you got that. But now they actually have a timeline graph of when your Northern European was likely interjected into your gene, when your West African was likely a portion of your gene, when the Ashkenazi or the Native American or the Caucasus region, whatever it is, which is very fascinating. Because then you can apply that to your ancestry.com type stuff and sort of see like, okay, it's not just that I'm part this, that, or whatever, but there was so they've drilled it down to when you were likely to have somebody who was say 100% South African in your history, and they can show you how many hundreds of years ago or whatever it is back that person would have been 100% considered Italian or 100% Irish or 100% whatever. So very fascinating. Excuse me. New infographics and tools have been added to the thing. And I love it because I paid for this 23andMe 10 years ago or whatever it was.
Yeah.
And it's still updating with new information. So for anybody who hasn't gotten in yet, hasn't taken that, and this is unpaid sponsorship. I paid them to be part of the thing. They have never given me anything. It's pretty cool that as they update and refine and add more detail and layer to this thing, you continue to get to participate with new information off of that same original donation of genetic material. So unless you've committed some sort of heinous crime that you're afraid of coming to light at some point, I suggest that you participate.
But shouldn't I be scared about them using my genome and making clones of me?
No, you should not. No, you should not. Unless you're highly paranoid and extremely egotistical about your place in worth in the world to the point where people will want to clone you for some sort of global takeover of the planet. You should
go on.
As somebody with elite genes, they could create and a high functioning multitasking intellect. They may create a future like multitasking, tangenting, mouth dribbling, constant talking assassin super soldier of the future who will talk people to death rather than use any form of projectile weaponry out of me. But in case the future doesn't go that way, I will at least get to know my past in the now, which is still worth doing.
Fair enough.
Know your past to prepare
also,
for your future.
Also, all of us humans are so interconnected that your particular specific unique genome could be sussed from the massive genes that they've already got. Like as unique as your particular selection and configuration is, ultimately there's nothing really that unique about.
Are you telling me I'm not special?
You are special in your configuration, but not in the components. You are made from the basic Lego set that the rest of us were built from. It's just you got the green Lego here instead of the red Lego, or you got the 8 peg instead of the 4.
Kiki, Justin said I'm not special.
No, that's not what I said. I said you're unique, but not special. You're not special. You're unique. You're one of a kind, as we all are. We're all knockoffs. But there's nothing you're hiding from the genomic world by not having your DNA looked at for one of these.
That is very high pitched.
Hey Blair. Hey Blair. Hey Blair. I didn't mean you specifically.
Made Blair
You specifically
sad.
are special, different. You're very different.
That's better.
You're very. You are.
She's
You
totally
are.
different.
You're like an abnormally. Really. You're that special. You're a complete anomaly. You don't. Everything I said, it has to do with those other people.
Portmanteau out of abnormal and anomaly, and I like it. We're an abnormally.
Abnormal. You're an
You're
abnormal.
an anomaly.
You're an abnormal for sure.
Oh yeah.
Oh,
Say goodnight, Blair.
Abby normal. Good night, Blair.
What's the brain I eating?
Yeah. Say good night, Justin.
Good night, Justin.
Good night.
Good night, Kiki.
Good night, all you specially abnormally wonderful people. You are unique. You put the you in unique.
This is my turkey.
Yes, you do. Gobble, gobble. I like how you have the waddle hanging down. There we go.
Snood. The waddle's down here. This is
The waddles, yes, you're right. The snood, the waddle and the snood. All right, everybody. Now that we know that, we got our turkey talk in. I hope everyone who is celebrating the day of turkey, that you enjoy the Thanksgiving and go into it with the spirit of gratitude in which it is to foster. Gratitude, thankfulness. Surround yourself with love and friends and family. I wish the best for you. Even if this is not your holiday, I do wish the best for you, and I'm thankful for you all. Thank you, co-hosts.
Thank you. I'm thankful for you.
Thank you, everyone. Let's have a wonderful weekend and get back in here next week. Got some neutrinos to talk about. I love it.
Wonton burrito meal.
Fantastic post
Science.
Thanksgiving. I'm actually more thankful for that show than for the actual Thanksgiving. I'm looking forward to that now.
Waiting
I'm
for
looking
it.
forward to that more than a stupid dinner.
Getting the Fermi Lab in there. All right, everybody. Good night. Thank you for watching. We'll see you next week.